In this example, we would like to find dy dx if x squared times x squared plus y squared is equal to y squared. And the graph of this equation looks something like this. The graph is symmetric with respect to both axes, the x and y axis, because of all the squares. And it actually has some vertical asymptotes when x is -1 and when x is +1. So even though this is not the graph of a function, because vertical lines, pretend that's vertical, will cut this curve in more than one place, we will still assume y is a function of x for the purpose of the calculation. So we assume y is a function of x, and we find dy dx, which will tell us the slope of this kappa curve. And the key is in implicit differentiation, assume y is a function of x. And the key is to begin the computation by taking the derivative of both sides. So you take the derivative of the left side and say it's equal to the derivative with respect to x of the right side. Now this left side, maybe it would be nicer to distribute for the purpose of the computation. It's nice to distribute the x squared. So this is the derivative of x squared times x squared is x to the 4th, plus x squared times y squared is x squared times y squared. And now to calculate these derivatives, we assume y is a function of x and we apply the appropriate product and chain rules. So the derivative first of x to the 4th is 4x cubed, and then plus the derivative of x squared y squared, that's a product, so that requires the product rule. First times derivative of second, which uses the chain rule, plus the second times the derivative of the first. And then that equals, on the other side, the derivative of y squared, that requires the chain rule. It's 2y times dy dx. So we get this wonderful equation here, which basically holds the answer. We want to solve for the symbol dy dx in this equation. So the dy dx's stay on the left or move to the left, and the non-dy dx's I'll move to the right. Or actually I'm going to do that the other way around, since the non-dy dx's are already on the left. I'll leave them on the left. So 4x cubed plus 2xy squared, that's the first and third terms on the left, I'll leave them there. And the right, I'll leave the 2y dy dx there. And this middle term that was on the left, I'll put that on the right. So it's going to be minus 2x squared y times dy dx. And the point of this is now on the right side, we can factor out dy dx. So it's dy dx times 2y minus 2x squared y. And on the right side, it remains 4x cubed plus 2xy squared. And finally, if we just divide both sides by the quantity in the parentheses here on the right side, we get a nice formula for dy dx. Let's put that over here. It's going to be dy dx equals the right side, the left side just stays on the top, 4x cubed plus 2xy squared, and then divide through here by what's in the parentheses, that's 2y minus 2x squared y. And that could even be simplified slightly. You could factor out a 2 and cancel it. On the top you could also factor out an x, but it won't cancel because you can't factor an x on the bottom. You could factor a y on the bottom, but not an x. But at any rate, if you do choose to factor out a 2, and cancel it, then on the numerator you'll have 2x cubed plus xy squared, and then in the denominator you'll have y minus 2x squared y. So that's the final answer. 2x cubed plus xy squared, that quantity over the quantity y minus 2x squared y.